Let us understand superconductors. In this video, I'll just give a short introduction of what superconductors are. Introduction. So basically, when the electrical resistivity of many metals and alloys drops suddenly to zero when the specimen is cooled to sufficiently low temperatures, this phenomenon is known as superconductivity. So basically, when it is cooled to a particular temperature, so that conductivity becomes infinite, or the resistivity of that material becomes zero. And the temperature at which the transition takes place is called the critical temperature. And the superconducting material above this critical temperature is in normal state, and below this temperature it is in superconducting state. The transition is not sharp for the specimen containing impurities or defects. So basically, as you can see here, that for the pure sample, the transition is very sharp as compared to the impure sample. So occurrence of superconductivity. It occurs that many metallic elements, alloys, it occurs in many metallic elements, alloys, intermetallic compounds, doped semiconductors, and in few organic compounds. The range of transition temperature lies between 90 Kelvin to less than 0.01 Kelvin, 0.001 Kelvin. So basically, there is always a requirement to make a superconducting material that is closer to room temperature or higher transition temperature, because it is very difficult to cool these materials to a very low temperature. Some materials become superconducting only under high pressures. So for example, silicon becomes superconducting at 165 kilobar with transition temperature of 8.3 Kelvin. So there are some material that they just don't need to be at that particular transition temperature, but also need a particular high pressure so that they can become superconducting. The paramagnetic impurities can affect the transition temperature severely. So for if we consider two same material, and one material has impurities, other is a pure, so the transition temperature of a material which has impurities will be quite lower, so which will be unfavorable. So we don't need a material that has very low transition temperature. That's why it is required to avoid these impurities or take pure material as a specimen. To discover more superconducting substances, B. Matthews formed a criteria which indicates the rule, the expected value of transition temperature, and the likelihood of observing superconductivity in substances. So basically, to discover more superconducting material, a set of rules were formed so that we can discover more such material. So the rules are rules are as follows. The valence number atom should be between 2 and 8, and the valence number which are nearly odd, like 3, 4.7, 6.4, are particularly favorable compared to the even ones. And the small atomic volume and the small atomic mass atoms are usually favored for superconductivity. And with this criteria, B. Matthews discovered thousands of superconducting materials.